we really see the first two day of fundamental in digital signal processing. So today we will talk about a very important issue. So remember that whenever we think about a look at a system, so a system is simply a box that takes an input as a signal and turn that into another signal, right? So the system is something a digital signal processing have to really design, right? We have some signal, let's say we have some like the example we saw in the first day of the MATLAB exercise. I have some ECG signal, which is have some noise added to it, and I need to design the systems so that the signal over here is clean, right? So you can see that we're given some input and we have to process it and provide the output. Okay, and on the first day we saw a very important class of systems. So if I can assume that this is an LTI system, if I can assume that is an LTI system, then all I need to do is to specify the HN, the unit pole response. So HN here is unit pulse response of that systems. And any LTI systems, the input and the output simply just equal to the convolutions of the input and the unit pulse response. The unit pulse, sometimes people would call it is impulse. Okay, so just let you familiar because we would call this thing differently. So either the unit pulse response or the impulse response of the system. So the system here is really just the output when I put in the impulse. Right? So I got that. And the output, the relationship between the input and output can be completely described by the convolution. And I left as an exercise, and we can easily show that the convolution in time is become a multiplication in frequency. So you can see that the process, so that is helping us analyzing this this kind of system. So far it's very abstract. But now we have to put ourselves in the perspective of someone. Now I have to construct this system. I have to develop these systems. Someone come and ask me to design the systems. So let's say you have to design a new generation of cell phone that meet a certain standard that required by the government, right? So the signal can only go through and have to meet a certain frequency characteristic. You have to design a cell phone, a mobile phone, and you have to design a system inside it. So confront with that task, you have to design out either this edge or this. And you can see this process here, because putting this form, this thing here, we can see that it's like a filtering operation. It's like a filtering operation. A filtering in the sense that the signal here has a certain frequency. So for example, as an example here, I can have the plot of omega here, and now if I have so the signal 0 to pi, and it will come out here, and then periodic extensions. So it has a signal then, and if we think about designing the filter, let's say the signal here is h of omega. So when you multiply h omega with h omega, this only part of the spectrum goes through. So that's why I put filtering, right? Just really filter out the thing that you like it to go through. So that's why we're going to the topic of filter design or filtering. But I need you to keep in mind that even though this, because of it look like a filter, but it is a very general LTI system. Any linear time invariant system can be considered as a filter. Okay, so even though you go out there and there's nothing has to be filtered, you need to design some linear time invariant systems. You just simply design a filter. Okay, all right. So with that perspective in mind, let's move on here. Now I'm going to put myself now in the context of a logic designer. Let's say I design a circuit, and I have an input and output. So you think about now. So now you think like a computer, right? This is mathematical analysis. So now let's think like a computer. So you have to think in the computer, the signal x. What is the signal x? Like in the MATLAB exercise we do, we create a variable now just like a vector. So the signal x is simply having this memory location. Each of them contain a sample of the signal, right? So for example, n plus 1, n minus 1, and so on. So each of these are just a location. So the signal here, and it might have start and end, or it may just go for a while. Let's say like my speech, right? I talk to a cell phone, the signal that keep coming. So now I have this big black box that I need to design, but what I need to get out, well, let's not draw the black box, but now let's see, how about I have an output. An output here is also a Y here, and it is also a signal, can be like that. And the job of the system, let's say I want to implement it, is having this signal, and I'm just going to fill out this slot. Right? I program a computer program to fill out this. I want to really construct a system. And let's say now, and when you compute the output, you compute one at a time. Right? You want to compute one at a time. So assuming that we are at this location, and here's n minus 1, and so on. One thing that people would typically do is, let's say I'm at this location. I am at that location. I need to know what is this value have to be. So what do I have with me now? I have my entire input, and I might have all of this sample already filled out, right? And now I simply have to compute this. Okay. So one simple way of doing that is a system called difference equation, and it's known as a DE. And the different equations is simply, when I compute this, I'm going to take this linear combinations of the input and the previous output. All the thing I have with me. And this operation can be computed very fast. So for example, I'm going to write yn equal to a1 y of n minus 1